transition from chapter 7, 3, and 4, and we are going to chapter 10. Jump into chapter 10. All right, I'll explain it in a second, okay? So, quiz 13 is something that I've got to give out. Oh no, and I left it on my computer.
Oh, okay.
God, I left it on the printout. So we'll pick up on that one. I was supposed to give you number 14, all right, today. All right, so let's very quickly, I want to go over the skills for 7.5 and 7.6.
Perfect.
Yes, okay. So this is because last week, with everything that was going on, we didn't have a lot of people here. All right, now 7.5 is long division. I need to bring it up. Okay. All right, long division. Now, all right, here is in Algebra 2, folks. All right, now listen to this. Okay, in Algebra 2, what's going to happen is that you're going to be given a problem that may look like this. All right, and what you're going to be asked to do is to divide it by a binomial. The binomial that you're going to divide it by is going to be x plus 4. All right, and so in long division, what you're going to do is you're going to multiply the x in order to make it look like the first term that you have available. In this case, x to the 4th. So when I multiply x times x to the 4th, if I multiply it by x third, x3 times that is x 4th. And then x3 times that is 4x third. Now, if one of these values of the exponents was missing, you'd have to put a 0 in its place, because these have to cascade down. 4, 3, 2, 1, and 0. Okay? Now, for long division, if you remember, for long division you subtract. However, it is not good to try to subtract integers. It's better to multiply what you just wrote by -1 and add them together, because you see the answer better. Right? So what I'm going to do is I'm going to come through here and I'm going to change the sign and make this negative and that negative. Now, when I add these two, I get a 0, and when I add these two, I end up with x to the 3rd. Okay? Now, I bring down my next term, which is -3x squared, and I want to multiply x by something and end up with x to the 3rd. That's going to be what? Plus x squared. Okay? So, x squared times x is x to the 3rd, and then x squared times 4 is plus 4x squared. Alright? Now, multiply by -1, change this to negative and this to negative, and that makes 0, but this will make -7x squared. Bring down the negative x. Now, what do I multiply x by in order to get -7x squared? I better multiply it by -7x. Okay. So, that gives me -7x squared, and -7x times 4 is -28x. Okay. Next step is what? Change the sign. So this becomes plus and that becomes plus, that's 0, and now this becomes 27x. Bring down the plus 5. And in order to be able to do that, I'm going to multiply by plus 27. And 27 times that is 27x. And 27 times 4 looks like 108. All right, change signs, negative, negative, and my remainder is a negative 103. So it's minus 103 over what? What did I divide by?
X plus 4.
X plus 4. And this is the remainder. Now, a lot of times, the values that you're going to use are going to give you a remainder of 0. But it doesn't always happen that way. So if you had this original quartic and you divided it by this binomial, you would end up with this cubic. And it would be x cubed plus, and if we multiplied this times this, because these two would cancel out, we would actually end up with a plus 5 on the end. So the math will actually work. Okay? All right, now that's long division. We can practice those. Come on in. We can practice those, but it's all going to be more of the same. Now, why do you need that? You need long division sometimes because what you're having to do is to break down a value so that you can begin to factor a larger polynomial. Right? So the first thing that you're going to do is look at what's called the remainder theorem. Right, what the remainder theorem says is that if you have x minus a, and you think that that is a binomial that's one of the factors, then you're going to replace, in the function, you're going to replace x with a, and when you do that, you're going to end up with a 0. If there is a 0 as the value, then you know that when x is whatever this number is, then you are on the x-axis with the value of a. And therefore that is one of the solutions. Alright, now, if you find a 0, if you find a value that is a solution, then sometimes you have to go with the long division and take this value and do long division to be able to get what this times some other polynomial as you begin to break it down. Now we're going to find today in the things that we're supposed to do today that there's a quick way when this is 1 x to the first power. There's a quick way. It's called synthetic division. And synthetic division is really quick and easy, but it does not work when this value is something more than 1. Okay? So that's why you need to know how to do long division. If you had to have 2x, and let's talk about that for a second. 2x minus 3 equals 0. What is x? Take the 3, move it over, and then divide by 2. What's x? 3 over 2. Okay? Alright, so when you have this form where the x has a coefficient other than 1, what you have is a fraction here. When x is 1, this is going to be a whole number.
Right.
It's going to be whatever a is. When you take the opposite of it and move it to the other side, that's going to be the value of x. Alright, so in long division, you can use all of this. But in synthetic division, you have to have a value of 1x. Right, that's the reason that you still need to know how to do long division in case you're given a problem that does not have a whole number as the value of x. Okay? Now that's the first thing. The second thing that I want to talk about that the book does not use that often is this. If you have px to the n plus, and then you go all the way down here, and then at the end you have, whoops, wait a minute, sorry, this is supposed to be p, this is q. Okay? If you have this, the number here is the constant, right? The factors of this, because again, if you say equals 0, what's going to happen to this p is going to go to the other side. So all of the factors of p divided by the factors of q are possible values for x. Okay, now let's see what that means. Suppose that this is a 6 and this is a 4. All the factors of 6 are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. 1 times 6 and 2 times 3. Okay? And the factors of 4 are plus or minus 1, plus or minus 2. So what are the possibilities for whole number values of x, or rational values? You could have over 1, you could have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Right? That's 2, 4, 6, 8 possibilities. Then I could have 1/2, right? That's 9. 2 over 2 is also 1, I've already got that. I can have 3 over 2, and I can have 6 over 2, which is also 3, so I've already got that. So you could have 2, 4, 6, 8, 10, you could have 12 possible values of x. Okay, now, how do you find out which one works? You go back and use the remainder theorem. You start with 1, and you see whether or not the function with x as 1, does it equal a 0? If it equals a 0, then that's one of the solutions. Okay? Now, the question is, if this is a 1, that makes x minus 1 the value. Alright, and so let's check negative 1. Negative 1 gives you some other number. Okay, that doesn't work. So then you check 2. Right? 2 doesn't give you the right number, but negative 2 does. So when f is negative 2, you get a 0. That means x plus 2. Why? Because when x is negative 2, what is negative 2 plus 2?
0.
0. That will make the polynomial 0. And then you keep checking. You'll check 3 and negative 3, check 6 and negative 6, and then you have to check 1/2, and you'll have to check 3/2. Right? And so you can actually find, and depending on what this exponent is, if this exponent is a 4, you're looking for 4 answers.
Right.
Okay? Now sometimes you find them and they're all real, sometimes they're not. Okay? So that is the values of the possible values of x is gotten from the first and the last numbers of the polynomial. And it's the last number divided by the first number, because to get x by itself, you're going to divide by that initial number, whatever it is.
Right.
That makes sense? So that's how you know which one goes on top, which one goes on the bottom. Now, I have seen tests where they ask you for what are the possible values for x. And that would be what I wrote here. Plus or minus 1, plus or minus 2, plus or minus 1/2, plus or minus 3, plus or minus 6. And that's those values. Okay? All right, now. So we've talked about 7.5. All right, now look on page 346. 346 is the values for long division. Okay, problem 2 I wouldn't worry about, but if you haven't done problem 4, problem 6, and problem 14, those are the ones you want to center on, because if you can get the correct answers for 4, 6, and 14, then you can do long division. Does that make sense? Okay, now, 7.6 is factors of higher polynomials. Okay, now turn over to 349. This is what I just told you about. If x minus b is a factor of the polynomial, then if you replace the x with a b, you'll get a 0. Now, if you'll notice, the value is the opposite of the number that's inside the binomial. Right, because you need to add the opposite of that number as x to the number in order to make a 0. Okay, you got to remember that. Okay, now in the middle of 349, do you see the factors of -12? Okay, see plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4. Now, why did they only give you the factors of -12? Look at what are you going to divide by? What's the leading number in that polynomial? How many x thirds is there? 1. And so when you divide by 1, it's still 12. That's the reason that it's not a fraction. Okay? Now, the Algebra 3 book that I taught from, they put a value in front of the x to the third power so that you had to have a fraction there, because there are times when you're going to see one. But the values that we have in this section do not have a leading coefficient other than the 1, and so that's why the numbers are a little bit less. Okay? Does that make sense?
Yes.
Now, when you turn the page to 351, if ax minus b is a factor, then b divided by a. Now, you see where that comes from? What do you do with the negative b? You add a b and then divide by a to get the x value. So if you put b divided by a into the polynomial and you multiply it out, if you get a 0, then you know that b divided by a is one of the solutions to that particular polynomial. Okay? All right. And so that's what you're looking for in 7.6. And that's all. Now, so now we're going to go to new stuff, which is going to be fun.
Yay.
All right. Now, let's see if I... Oh, wow, that was weird. My ear just went off. Okay, that's not it. That's next week. Okay. So we've done 7.5 and 7.6. Looked at those. All right. Now we're going to jump down to section 10.
Are we skipping everything in between, or just like temporarily skipping everything?
Yeah, we're going to go to 10 and then back to 9 and then come back. Because what they're doing is they're trying to get some things that are similar and go together, and there's not a problem with that. Okay, now let's get to the right section on page 519. Actually, turn back on 517. Okay, 517. All right, the first thing that we're going to talk about is imaginary numbers. Now, when I taught 6th grade, I used to introduce imaginary numbers in 6th grade because 6th graders thought it was cool. And especially because the 8th grade was doing it as part of their Algebra 1. And so my 6th graders would take the same test as the 8th graders. And with imaginary numbers, this first part is very straightforward. Okay? All right, here's what happens. By definition, the square root of -1 is equal to I, an imaginary number. Okay? So square root of negative. So what happens when you square I? You'll get -1, the square of the square root, which is going to be -1. Okay, so by definition, I squared is -1. You've got to remember that. Now, what happens when we take this and add another I? -1 1 times I is negative I. So when you have 3 i's, I to the third power, the value is negative I because 2 of these make a negative 1. Does that make sense?
Mm-hmm.
Okay. All right. Now, for the fourth one, 2 of them make negative 1, and the other 2 make negative 1, and negative 1 times negative 1 is
Positive 1.
positive 1. Okay?
Yay.
So here's what's going to happen. You're going to be given I to some big number. All right? And what you're going to want to know is what is the remainder when I divide it by 4, because every group of 4 i's produces the value of 1.
Gotcha.
All right? So let's say that I gave you I to the 17th power. What is 17 divided by 4? 17 divided by 4 is 4, right? Now, but I don't care what that value is. What I want to know is what's the remainder when I divide it by 4. No, come on now. The remainder is 1. 1 over 4, right?
Gotcha.
The remainder is 1, right? Therefore, I have 1 I left over, and so this equals I. Because there's 1 I left over. Right? It's I times I to the 16th. Every 4 of those is 1. So that's 1 times 1 times 1 times 1 times I.
Right.
Okay? Now, suppose I gave you I to the 22nd. Okay, divided by 4, what's the remainder? How many times is 4 going to 22, people? 5 times. 5 times 4 is 20. What's the left? 2. I squared is negative 1. So that makes this equals negative 1. Because it's I squared. I to the 11th. Divided by 4. How many times goes in twice? What's the remainder? 3. The remainder of 3, this equals negative I.
Gotcha.
Alright? And then the easy one. I to the 40. What's the remainder? 0. So the answer is 1. Because any group of 4 makes 1.
Gotcha.
Okay? Yeah, that's a test problem. Hard or easy?
Easy.
If you can't divide it, it's really tough. But provide now. Okay, now I saw somebody handed use the calculator. All right, if you get 0.25, that's 1/4. Therefore, that's 1 remainder. If you get 0.50, that's 2/4. That's 2 remainders. 0.75 is 3/4. That's 3 remainders. And if you got a whole number, you have 0 remainder. All right, now, complex numbers. Complex numbers have both real and imaginary. All right? A is the real, and BI is the imaginary. Sometimes there isn't. Sometimes it's just I. Sometimes it can be 4i, square root of 2i if we're doing a quadratic formula. All right, now, here's something that the book says that you just have to know. If you have an imaginary number, it will come in pairs. Conjugate pairs. Now, what's the difference between these two binomials? Notice all the letters are the same? What is different? The signs are different. Conjugates are the same value with different signs. Okay? Now, what did I write in red way over in the corner?
Sum of squares.
Sum of squares. We, in real numbers, use difference of squares.
Right.
Right? If you had 4x squared minus 25, that's a difference of squares. So in real numbers, this is 2x plus 5 and 2x minus 5. Right? If they are complex conjugates, because I squared is going to produce -1, instead of subtracting, you're going to add. Okay? So, let's say that I gave you this. Suppose I gave you 3 minus 2i and 3 plus 2i. Okay, now, normally conjugates produce a difference of squares. So what is the square of the first number? Come on, folks. What's the square of the first number? 9. What's the square of the second number? 4. Right? But because it's imaginary, because it's complex, add them. 9 plus 4. 13. That'll be the denominator of a fraction if you were rationalizing the I out of the denominator. So if this was the denominator, you'd multiply it by its conjugate, and you're going to have 9 plus 4. But if it was up here, if this I wasn't here, what would it be? It'd be 9 minus 4. Right? Okay, so the I is going to change it. Right, now that takes care of an entire section in section 10. Right, pretty simple, pretty simple. Okay, now the next thing is cool. I did not know this one. I may have been taught this at some time, but I did not know it when I wrote it. Okay, all right. What do you see here? What is this?
Confusing.
It's a quadratic equation, right? X squared plus some number times x plus some number, right? So that's a quadratic equation. Now, here's what happens. S1 and S2 are the two solutions, look, the two solutions for this equation, right? The middle number is the sum, the opposite of adding the two numbers together. The constant is the product of the two numbers. Okay, now right now that doesn't make any sense, does it? Okay, all right, so let's assume that I tell you that 2 and -5 are the solutions for this quadratic equation. Okay? Now, that means the equation is going to be x squared. Now, I want the opposite of the sum of those two numbers. So add these two numbers together. What do you get? -3. The opposite of it, plus 3x. Now, the last number is the product of those two numbers. That's the equation for which those two numbers are the solution.
Perfect.
Okay. Okay. Opposite of the sum is the middle term, and then the product is the last term. Okay. So let's see you do one. Let's say that -1 and 7 are the two solutions. What's the equation? Opposite of the sum.
-7.
So where does that go?
-7 is bottom, so it'd be x squared plus 6x minus 7.
Well, wait a minute, I'm sorry.
Shouldn't it be plus 6?
Opposite 7 plus -1 is opposite of the sum,
Yeah.
and then the product. Okay. All right. Now. Okay. Now I want to talk to you about synthetic division. Have you heard of that?
Yes.
Okay. Synthetic division is going to factor a number. Let's see, I need to. Where's this thing over here? Okay. All right. Here's my polynomial, and I'm going to divide it by a binomial x and something. Okay, x plus or x minus a. Okay. Now, what's going to happen is I am going to list the coefficients of the x4, x3, x2, x1, and x0 terms. I'm going to list those coefficients. Right? So if you'll notice, I have 1, 2, -5, -7, and 2. Now, this line right there is not there when you start. What you do is you skip a line because you're going to put those numbers there and you draw this line. So do that on your paper. All right, you're going to skip the line that has the numbers on it, you're going to draw this line, and you're going to bring this 1 down. So this 1 starts here. The whole key to being correct on synthetic division is that first step. If you bring this 1 down to here, everything else will work in place. Now, if x minus 2 is the binomial that I believe is true and makes a 0, then what does x have to be to make this a 0? Look at what I'm pointing at. What value of x will make this 0? It's 2, therefore that's the number I put here. You don't use -2, you use 2. That's the value of x. Now, this is a shorthand for doing long division. Only it's going to go just like that. Okay? So, what is 2 times 1? 2. Put it right there. Now, add. Remember what we did with that we multiplied what we just did in the long division by negative and then added? That's what we're doing now. So add these two and get 4. Okay, now, what is 2 times 4? 8. Add those together.
Gotcha.
Get 3. Alright, what is 2 times 3? 6. Add those together. -1. And what is 2 times -1? It's -2, and that's 0. And the 0 remainder is the reason that I chose to do that one, because I knew it was 0. Okay, now, here's what happens. This is now 1x less, because I divided by 1x, so this 4 is now a 3. So this is 1x third, 4x second, 3x minus 1. This times this. Now we got to do it again.
Oh, cute.
Alright? Now, the question is whether or not we can find the value. So how do we find it? Alright, let's check. Because I have a 1 here and a 1 there, let's see what happens when x is 1. This is 1 plus 4, 5, 8, doesn't make a 0. What happens when x is -1? This is -1 plus 4 minus 1, or minus 3, minus 1. Okay, and it turns out, and I didn't go that far, it turns out that's going to be prime. Because we don't have another value. The only value of P over Q will be plus or minus 1, and neither of them work, so that's a relatively prime number. So it makes a bad example if we wanted to continue. Alright, but I was setting this up. Okay, so that's synthetic division. Now, if you understand that, that's all there is to synthetic division. Okay? Alright, so let's look at the textbook and see if we can do a couple of these. Alright, that's 10-4. Okay, turn to page 540. 540. Let's look at problem 12. And problem 12 says x cubed minus x squared minus 4x plus 4 equals 0. Okay? And let's do synthetic division with x minus 2. Right? Now, what is the divisor that I'm going to use if my binomial is x minus 2? What value will make that binomial into a 0? It'll be a 2. And this is 1, negative 1, negative 4, and 4. So there's the start of your synthetic division. Alright, now what is 2 times 1?
2.
2. Right, when you add them together, you get 1. Now, what's 2 times 1?
2.
Add them together. And what is 2 times negative 2?
Negative 4.
Negative 4, which makes my 0. Whoops, I want to put an X there. Alright, now I don't write that 0 there. If it was a remainder, I'd write it. Now, that means that this is x squared plus x minus 2. And my other one is x minus 2. Now, can anybody factor that second trinomial? What are the factors of negative 2 that add up to 1?
1 and negative 1.
X plus 2, x minus 1, right?
Mm-hmm.
Okay, and so that means that the trinomial is that. Now, watch this. If I were to factor this, this is x squared and x minus 1. Right? This is negative 4 and x minus 1. So this is x squared minus 4 times x minus 1. And this is x plus 2, x minus 2, x minus 1. Now, which was faster? The synthetic division was a lot faster.
Yeah.
Right? Okay. So this was the old way. Whenever you have 4 terms, one of the things that you can try is grouping. And when you group the first 2, you ended up with a common binomial of x minus 1. And it was nicely worked out that the x squared minus 4 is a difference of squares, so it's x plus 2, x minus 2. And so it's the same values. Right? But this is not going this way. That we don't do it that often, do we? Right? If we knew that x minus 2, that 2 was a solution, and x minus 2 we can simplify with synthetic division.
Right.
Right? And this is used a whole lot more. Now, what would happen if we had a number here? Let's say that this was an 8. And this would be 4. That would be 4 over x minus 2 as the remainder. Just like when we were dividing with long division. You would still have the same thing. Okay, questions on that? Yes?
I don't entirely understand where you're getting all of the numbers from.
Okay, all right, good. All right, let's go back. Let's go back to on this top part or on the bottom part? Which? The bottom, okay, all right.
Yeah. Well, like the second line.
Okay, all right, let's,
Yes.
okay. What you're doing when you do synthetic division is you are multiplying and adding. Okay? Now, what happens when we did long division is that we found out what number we had to multiply by, right? We wrote it down, then we changed the sign and added, right? And so we're doing multiplying and adding the same things that we would have done, except our form is different, right? So when I bring this 1 down, all right, the question is, where did these 4 numbers come from?
Yeah.
They came from the coefficients up here. 1, -1, -4, and 4. Okay? Now, what didn't I write? I didn't write x to the third, x to the second, and x.
Gotcha.
Right? But they're in order. Right? They're cascading in order. So if I would have given you this, x to the 5th minus 2x third plus 4x squared minus x plus 2, what's missing? You see that x to the 4th is missing? So my numbers would be 1, 0, -2, 4, -1, and 2. So that I have 1, 0 for the x fourth, -2, 4, -1, and 2, and then whatever I'm dividing by, we'll set up like that. Okay? All right, okay, good question. All right, now, okay, so what do we do now?
Bring the 1 down.
Multiply, you got the ones down, multiply, and then add. Multiply, then add. Multiply, and that's 0, and so I know that because this is 3, this is 1x squared plus 1x minus 2 and x minus 2. And then I have to factor this, which hopefully you can see that one,
Yeah.
because that's a 1, so it's the factors of -2 that add up to 1.
Mm-hmm.
So it's -2 and +2 and -1. Okay? Alright, so let's look at another problem on that page. That was number 2. Alright, now, hang on just a minute. I don't think I'm trying to see if there's actually, no, there's not. Okay. Alright, so problem 30. Problem 30. It says x cubed minus 6x squared plus 13x plus or minus 10. Okay, now, what are if we have zeros that are whole numbers and are rational, they have to be factors of 10. So I'm going to check plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10.
Right.
All right, so just for, because I haven't worked it, so let's say that we want x plus 1. Okay, what will be my divisor number? This is important. -1. So I'm going to have a -1 here, and then I'm going to have 1, -6, 13, and -10. Okay? So, -1 times 1, -1. Add, -7. What is -1 times -7?
7.
7. Add it, 20. -1 times 20. And so this is -30 over x plus 1. So this is not a whole number factor. Right, now how do we interpret this? Because this is x3, this is x squared minus 7x plus 20 minus 30 over x plus 1. Okay? Now, if we wanted to find out what happens when x is 1, now let's look. This would be 1 minus 6 plus 13 minus 10. So negative 16 and 14, that's not going to be a 0 either. So 1 and negative 1 are not factors of this. What do you think? Okay, somebody check 2 with a calculator. What's 2 to the third power? 8. Right? This is 8 minus, that's 4 minus 24 plus 26 minus 10. That looks like it'll do it, doesn't it?
Yeah, 0.
Huh? Okay. So therefore, if x is 2, x minus 2 is what I'm working with, right? So let's do another one. And this one we know is going to 0 out. So what's the first thing? This is a 2. First step, 2 times 1, 2. Add, negative 4. 2 times negative 4, negative 8. That's 5. 2 times 5, 10. 10 plus negative 10 is 0. So that makes this x minus 2 times x squared minus 4x plus 5. Hopefully, what are the factors of 5 that add up to negative 4?
1 and negative 5.
No,
No, negative.
won't work.
Wait.
So therefore, this is going to be a complex number. It's going to be imaginary. Because if I have b squared, 16 minus 4 times 5 is 16 minus 20, it's negative 4. So that's going to give me a 2i. Right? So that's going to be an imaginary number. But, so I have this. Now, remember that, okay, if we start this, we're going to have the opposite of this, 4, and I just calculated the other part in my head, plus or minus 2i over 2. So what will that be? 2 plus I and 2 minus I. So this is x minus 2 and x plus I, x minus I. One real, 2 imaginary. Okay, yeah. Yes. Right, one thing. Alright, so if I were graphing that, my graph is going to either look like this, or it's going to look like this.
Gotcha.
Right, because I'm not going to have it going through 3 times. It's only going through with one real number and 2 imaginary. So it's going to hit 1 time in wait a minute, because it's positive 2, it would actually be over here. This thing would be over here. So it's going to be like that, or it's going to be like that. One of those 2. Because the imaginary number is going to be 2 of the points that will not show up on the graph. It only crosses the x-axis 1 time. Okay, question? All right. That's 10:06. Wow.
Alright, now can I go to the...
Now you may think.
Yeah. Thank you.
All right. Now. Okay, go to page 527, please. Yep, 527. Okay. Are there factors of 13 that add up to negative 2? The answer is no. Therefore, we have to use the quadratic formula. All right, quadratic formula says the opposite of b plus or minus the square root of what?
Quantity b squared.
B squared, which is 4, minus 4 times A times C, which is 13, all over 2A. Okay, so you have to find in your calculator 4 minus 4 times 13. Okay, want to see something cool? This is 13 fours. That's 1 4, so it's 12 fours.
Whoa.
That's 13 fours, right?
This is
This is 1 4, so that's 12 fours, right? So it's going to be negative 48.
Wait, negative.
Yeah, because the negative was with a 4.
Oh,
Okay, so it's negative 13 and then positive 1, negative 12. So this is the square root of negative 48. Okay, now, all right, how many 4s do I have? All right, this is 4 times 12, right?
It's a 12 course.
This is 4 times 12, but 12 is 4 times 3.
No.
So this is 16 times 3. Square root of 16 is 4. So all of this is going to become 4 square root of 3. All right, did I go too fast? You want to see that again? Okay. We had negative, we had 4 minus 4 times 13. That in the calculator is negative 48. So I have the square root of negative 48. All right, now, what's 4 times 12 is 48?
Mm-hmm.
Right? So this is negative 1, 4 times 12, but 12 is 4 times 3. So that means the square root of negative 1, the square root of 16, and the square root of 3. The square root of 16 is 4, square root of 3 stays under, the square root of negative 1 is on. Now what happens when we divide it all by 2? What's 2 divided by 2? 1 plus or minus, and then this will be 2 square root of 3 I. So it's a complex number. 1 plus 2 square root of 3i, and 1 minus 2 square root of 3i. So that's solutions. Okay, so what does that tell us about this? Does this quadratic, does it cross the x-axis? If there's no real solutions, it does not cross the x-axis. What happens when x is 0? Y is 13, it's way up here. And it opens upward.
Oh, yeah. I see.
Okay. All right, let's see. Now, example 4 on page 527. All right, if you'll notice the solution, you see where they took that power of 5 out? See, they took the power. What happens if you left the power of 5 in? Then you have negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. What's 2a? 2a is 10, right? So So the value of 10 is going to be in the denominator anyway.
Right.
Okay? All right, and I would not make it a fraction. I would just use the quadratic formula and just solve that using a b of 3, an a of 5, and a c of -7, and just do the math. Okay, that one doesn't have as great an answer as you would think. Okay, all right, now that takes care of that section. Let's go back one more to 10.2. Okay, 10.2, page 519. All right, now, if you remember when we said that the sum will be negative S1 plus S2, that'll be the middle term, and the product will be S1 times S2. Okay, let's look at example 2 and do that same thing with imaginary numbers. Okay, now we find that S1 or Z1 is 7 minus 8i, and that Z2 is 2 plus 11i. Okay, now what happens when you add those two together? 7 plus 2 is 9, and then negative 8 plus 11? Positive 3. Positive 3. So if I take the opposite of that, it'll be minus 9 minus 3i.
Yeah.
Right? That's the middle term. Now, what about the product? What's the product of these? All right, so you're going to take, what's 7 times 2? 7 times 2, 14, and then 8 times 11 is 88, and the I squared and the negative will make it plus. All right, so you've got 14 plus 88.
102.
And then, all right, now, and then the inside is negative 16, and the outside is 77.
Right.
Okay, and so that ends up being 61. All right, now, turn to page 520, look at example 4. All right, notice their conjugates. See their conjugates?
Yeah.
So we're going to get the sum of the squares. So what's the square of 4? Square of 4? Not square root, square. 4 times 4? 16. And then square of 9? So add 16 and 81? 97. All right. Okay, now example 5, in order to rationalize an imaginary number, you cannot leave the I in the denominator. So we have 4 plus 3i and 5 minus 2i. Okay, in order to be able to get rid of the I, we have to multiply by the conjugate of the denominator. So, what is the conjugate of 5 minus 2i? Plus 2i. 5 plus 2i is the conjugate. Right? Now, we have to multiply by a value of 1 so that we don't change it, so the top is that. Now, this is the sum of the squares. So it's 25 plus 4. That's the reason I'm trying to point that out to you. Just like without the I, it would be the difference of squares, which would be 25 minus 4.
Yeah.
Right? Because it has the I and it's a complex number, it's the sum of squares, 25 plus 4. Now what happens on the top? On the top we have 20, and then we have 6i squared. So that's 20 minus 6. And then the inside is 15, and the outside is 8. 15 plus 8 is 23i. So this becomes 14 over 29 plus 23 over 29i. Right? Okay, question? All right, so let me find my, there we go, it's over here. Yep, there. Okay. All right. Keep saying that for me. Okay. All right.
Oh, wow. That's a lot.
That was for me.
Okay.
Okay, so we are finished. So here is, all right, so your assignment. Now, I'll give you this quiz next week.
Okay.
All right, and your assignment is to do 10.2 through 10.4.
Okay.
I think here's the parts. All right, so 10.2 you're skipping 4. You notice you're not doing all the numbers. All right, and then in 10.3 you're only doing just about 6 numbers in 10.3. And then in 10.4 you're just doing a few numbers as well.
50. Sounds good.
Oh.
Yes, oh,
Okay.
sorry.